In this video, I'm going to set up the Anaconda Python distribution on a Windows 11 PC, and I'm also going to install Visual Studio Code and configure it for use with Python. Before getting started, you should make sure you have a clean install of Windows 11, i.e. an install that doesn't have any previous Python installations on it. So in order to use the Windows Package Manager, WinGet, we need to make sure that all the applications pre-installed with Windows 11 are up to date. So open up the Microsoft Store and then select Library to the left hand side, and then select Update All. And you want to make sure the Windows Terminal and the app installer are up to date. Right click the Start button and select Terminal. You want to select Terminal User and not Terminal Admin. And this is because we want to install software as a single user. So we're going to type in WinGet, search, and then Anaconda. And here we're going to get the ID for Anaconda. So it's anaconda.anaconda3. So we're going to type in WinGet, install anaconda.anaconda3. And WinGet is essentially going to download this 1.02 gigabyte installer and then silently install it in the background. So once Anaconda is installed, you've got some start menu shortcuts. You've got the Anaconda PowerShell prompt and the Anaconda prompt. The PowerShell prompt should be preferentially used because the other prompt uses CMD, which is depreciated. So if we have a look at the start menu shortcut to the Anaconda PowerShell prompt, we can see that it runs PowerShell, which is essentially what is ran in the Windows terminal. Now it bypasses execution policy and runs an external script. And this external script is used to activate a Python environment, which is the base Python environment by default. So if you open up the Anaconda PowerShell prompt, you see the base Python environment listed to the left hand side. Now if we have a look at the Windows terminal in contrast, we see it looks very similar. So instead of running this script, it's linked to the environmental variables path. So we can have a look at this environmental variables path, and we can see we've got essentially a user profile and an Anaconda free folder. So basically the Windows terminal is going to look in this folder for the python.exe when Python is typed in the Windows terminal. So notice there's a python.exe in this folder. And if we type in the full path, we can run this exe. If we just type in python.exe, because it's looking in this location, it's going to go to this folder and then see there's a python.exe. And we don't even need to type in the .exe, we can just type in Python and we get the same results. So in the path there is also the script subfolder. And if we explore this, we see there's a number of additional programs. One of these is the Anaconda Navigator. So if we go ahead and just launch this exe using the full file path, we see we get the Anaconda Navigator launching. So the Anaconda Navigator is essentially a graphical user interface, and it essentially contains start menu shortcuts to the most commonly used Python applications. And two of the most commonly used applications, for example, are Spyder and JupyterLab. So we can see we've essentially got a start menu tile to these applications. If we select launch, we're going to launch Spyder. So I'm just going to close Spyder down now and also launch JupyterLab. So JupyterLab is a browser-based application. So essentially a server is being run in the background and the visual elements are displayed in the browser. So I'm just going to close the tab now and now close down the Anaconda Navigator. The JupyterLab server is still going to be running in the background, so we need to tell it that we want to close it. Now, because the scripts folder is added to the path, I can just type in Anaconda-Navigator to launch Anaconda Navigator. Now, if I have a look through this folder, I can see other applications. So, for example, we can see Spyder, and we can launch Spyder by just typing in Spyder. And we can also see JupyterLab in this list. So we can just type in Jupyter-Lab. And it's going to run the server in the console. So while the server is running, the console will be busy and the visual elements will display in the browser. Okay, so the visual elements are displayed in the browser to the right, and the server that's being used to run JupyterLab is shown on the left in the terminal. So when we close down the browser, the server is still running and we need to press Ctrl and C to cancel the operation. So Ctrl and C will essentially close or cancel an operation. Ctrl, Shift and C is used to copy, and Ctrl, Shift and V is used to paste. So previously we used the Windows package manager WinGet. Now Python has its own package managers, and the important one in the Anaconda Python distribution is called Conda. So if we type in Conda, we get details about all the subcommands we can use with the Conda package manager. So let me just open up the Anaconda PowerShell prompt and then select Conda deactivate. What I'm going to do now is use the Conda package manager to update Anaconda. So the first thing I want to do is go to user profile and check if there's a .conda.rc file there, and if there is, that it's using the default settings. And then I'm just going to type in conda update conda. So what this is going to do is it's going to update the Conda package manager, and in turn this is going to update the Anaconda Python distribution. So there should be some details about the packages that are being changed. So most packages will be updated, a very small number will be removed, and some new packages will be added. And this will also update the solver used in the Conda package manager to the more modern solver, which is faster and more reliable. So once the Anaconda Python distribution has been updated, you'll see a new prompt. So now that the Anaconda Python distribution has been updated, I can activate the base Python environment using the command conda-activate base. And if I have a look in the scripts folder, notice I've got the application IPython, which is interactive Python. So if I go up a level back to the Anaconda 3 folder, notice that there is a lib subfolder which contains Python's standard modules. So here we see a standard module, datetime.py, and we can import it by just typing in import datetime, and we can see that this is the physical file. Some of the other modules are larger and are a number of Python script files contained within a folder. So for example, we've got the folder email, and within this folder there's a special initialization file called dunder init. Dunder means it starts and ends with a double underscore. And the other modules in this folder are referenced with respect to the folder. Third-party libraries, which are developed separately from Python but included with Anaconda, are in the site packages folder. So one of the most common third-party libraries is numpy. And notice we've got a numpy folder. And in the numpy folder is the dunder init. So numpy is imported using a two-letter alias, np. So we type in import numpy as np. And if we have a look at its data model attribute dunder file, we can see the location of this file. So numpy is a very large library, and notice it's got a number of subfolders. So for example, if we have a look at the random subfolder, we can see that it's also got its own dunder init. So when we type in import numpy.random as random, we are referencing this file. So another commonly used third-party library is matplotlib. And if we have a look at its folder, we can see that once again, we've got dunder init. So if we type in import matplotlib, then we're going to reference this file. However, normally when we use matplotlib, we don't actually use the entire library. We only use a module, which is the pyplot module. So when we type in import matplotlib.pyplot as plt, we are referencing this pyplot file. So in general, the Anaconda Python distribution is a Python distribution, and it should be updated collectively using the standard images provided by Anaconda. If you want to install your own packages, you're going to need to make a custom Python environment, and that's essentially a sub-installation. So to do this, we are going to use the command conda-create and then -n and then specify the name of the Python environment. And all Python environments apart from base are stored in the envs subfolder. So notice now that there's this JupyterLab subfolder, which is the JupyterLab Python environment. So what I'm going to do now is use the conda install command to install Python, JupyterLab, and a number of data science libraries that are commonly used with JupyterLab. So if I have a look at the versions, I see I've got JupyterLab 3 and Python 3.11. Now these are the versions that are currently tested by the Anaconda company for stability with their Anaconda Python distribution. And these are generally behind the latest versions, which are released by the Python community. So essentially the Python community make the latest version of all the packages, and then the Anaconda company test some of these packages for use with their Python distribution. So if we change the channel from defaults to conda-forge, we're going to look at the community channel instead. And notice we've got a newer version of Python, Python 3.12, and we've got a newer version of JupyterLab, JupyterLab 4. We can also install some other packages that are available from the community that aren't included in the Anaconda Python distribution, such as the JupyterLab Variable Inspector, which is a third-party extension for JupyterLab. So if we have a look at this Python environment now, notice that it's got its own python.exe. And since this Python environment's activated, If I type in Python, then this is the Python version that's used. It's also got its own script subfolder, and so we can use this to launch JupyterLab. And the JupyterLab.exe being used is going to be the newer JupyterLab from the JupyterLab Python environment, which is the activated Python environment. So if I go to help and then about, I can see that this is version 4. So once again, I'm going to need to press Ctrl and C to close the server. And now if I activate base and type in Python, notice I've got the old version of Python, which is the version maintained by the Anaconda company. And if I activate JupyterLab and run Python, then I'm using the latest version from the community channel. So if I activate the Python environment JupyterLab and launch IPython, I'm going to launch IPython from the scripts folder that's found within the JupyterLab Python environment. And if I go up a level, I can see that this Python environment has its own lib subfolder. And if I go to the email subfolder here, it's the email standard module that's included in this Python environment. So we can see also if we import numpy as np, then we're going to be using the numpy in the site packages folder of this Python environment. So let's now just compare the Windows terminal to the Anaconda PowerShell prompt. So the Windows terminal is using the Windows environmental variables path. So notice that when we type in the conda-activate JupyterLab command, that it does nothing. And the Python that's being used is always going to be the Python that's specified in the Windows environmental variables path. So therefore, the Anaconda PowerShell prompt should be preferentially used when managing Python environments. The Anaconda PowerShell prompt is ran as a user, and so we can use WinGet. So we can use WinGet to install Microsoft.VisualStudioCode. And this will download the Visual Studio Code setup, and it will silently install it, although you will actually see the installation process proceed. So Visual Studio Code is a general purpose code editor, and a number of extensions need to be installed for Python functionality. The first one is the Python extension. I recommend also installing the Jupyter extension, which will allow support for interactive Python notebooks. The import sort, AutoPep A and Black extensions are maintained by Microsoft and are essentially Python auto-formatters. So installing these will allow you to auto-format your Python code. There's also a third-party auto-formatter called Ruff, which isn't as stable as the other auto-formatters that have previously been mentioned, but is a bit more powerful. So this can also be installed. So now that these are installed, what I'm going to do is create a new project, which is essentially a folder which contains code files. And we can essentially create a Python script file, or we can create an interactive Python notebook. So the interactive Python notebook consists of a series of cells, and these can either be Markdown or they can be code cells. So the Markdown cells, for example, can be used for headings. So when we want to run the Python code, we'll need to select the Python interpreter, and we should select the Anaconda base Python environment. So spacing is pretty important when you type in Python code. And in particular, you should try to be compliant with PEP 8. So generally for assignment and use of another operator, you're going to put a space around it to emphasize it. However, when you are using a function call, the spacing is going to be used to emphasize the delimiter. So even though you've got an assignment operator for a keyword input argument, you're not going to put spaces around it. Instead, you're going to emphasize the delimiter. Also, import should be generally at the top of the script file with standard modules first, followed by third-party modules, and then generally listed in alphabetical order. So notice when I press Ctrl Shift and P and select Format Document With, I can use Auto PEP 8, which is going to correct some of the spacing. And if I use Organize Imports, then it's going to organize the imports with the standard module first, followed by the third-party DataScience Libraries. And notice that these two categories are in alphabetical order. So I can use some of the other formatters such as black or Ruff, and these can be used to carry out additional opinionated formatting, such as the preferred quotation style used in strings. Now, unfortunately, these use double quotations, whereas the standard library uses a single quotation. So I would recommend sticking to a single quotation and trying to be as consistent as possible to the Python standard library. So for Ruff, you can actually create a configuration file. So you just create this ruff.toml file, and we can just copy the defaults. And what we want to do is change the quote style from double to single. And notice now that when we use format document with Ruff, that the quotations are now using single quotes. So let me just copy and paste some of the sloppy code into the notebook file. So if I press Ctrl Shift and P to get to the command palette, I've got the command format notebook instead of format document. So I can format the notebook with Ruff. And one thing to note about formatting a notebook is we are generally less stringent with the import sorting, because we generally don't need to put them all at the top. Sometimes we will just import something and demonstrate how it's used as we go from the top to the bottom of the notebook. In this case, I'm going to put my imports at the top. So I'm going to import the libraries, and then I'm going to set this style to white grid, and then I'm going to create some data. So I'm going to create an X and a Y array. And notice that I can use the cell output of a notebook to view these arrays. And now I'm just going to create a data frame from these. So a data frame is basically a Python implementation of an Excel worksheet. And I can use these data structures to plot the data. So let's plot Y with respect to X. And seaborn basically bridges pandas and matplotlib together. And so we can create the seaborn plot. We also have the variables tab, so we can visualize the variables that have been created. So Visual Studio Code is a general purpose code editor, and it has support for a Markdown file as well. So the Markdown file can be used in a notebook, or it can also be used to write documentation. And a project generally has a readme.markdown file. So you can use Markdown to essentially create a very basic document. So this can have formatted text, it can have bullet points, it can have tables, and it can have code. So the code can be inline or the code can be in a code block. You can also add mathematical expressions, links, and images. Visual Studio Code has the Markdown preview, and you can open the Markdown preview by right-clicking the Markdown file and selecting Open Preview. And you can view this side by side when you're editing. So I went over a lot of my notes after reading some intermediate Python texts, and they're basically all in notebook format or Markdown. So if you want these, what you can do is just go to GitHub and select code, and then download the code as a zip file and extract the zip file. So if I just extract this zip file and copy it over to Documents, and once it's extracted, I can open up this project in Visual Studio Code. So let me just save the files in the existing project. So you'll notice that I've got a readme.md, and you can open this up as a Markdown preview if you want to see the formatted document. And I can just select one of the notebooks, and generally you're going to want to clear all the outputs and run the cell one by one as you're reading it. And because it is a notebook, you can modify the Markdown to give yourself additional notes, or modify the code slightly just to see what happens and experiment and play around. So the interactive Python notebooks, as the name suggests, should be a pretty interactive way for learning Python. So feel free to star the repository, and this will make it a bit easier for other people to find. You can also fork it if you want your own local copy on GitHub. So basically it's going to cover the inbuilt classes, some programming constructs, and then some of the standard libraries geared more towards data science. And then it's going to focus on the main data science libraries, which are essentially the foundation of data science for Python.